We already have a pretty good idea that momentum is a good lens to use to solve a problem involving a collision. But collision can mean a lot of different things. And when you look at a problem, it might not be obvious it's a collision and to use momentum. So I wanted to talk about what we call collisions in physics. Maybe you should think a little bit about what jumps into your mind when you hear the word collision. In physics, one type of collision is when one object becomes multiple objects. In other words, it blows up. An example of this could be two ice skaters standing pressed up next to each other on center ice, and then they push off each other and they move in opposite directions. Or an explosive, where the gunpowder or whatever it is goes off and causes pieces to fly out in different directions. One object becoming multiple objects. The second thing that comes to mind when we think collisions is just the opposite, when things collide and stick together. When multiple objects become one. In other words, they stick together. This often happens in car accidents. Two cars collide, and then the cars get wedged together and move off in the same direction, stuck together. Or if you throw a clay ball at something and it hits it and sticks to it, and the two objects move as one. Or maybe you've shot a piece of wood with a gun, with a bullet, and the bullet gets lodged inside the piece of wood and it moves together. Those would all be examples of this type of collision. And then the third thing is probably what came to mind immediately when you heard the word collision, and that's objects bouncing off each other. Let's think about our first type of collision for a second. We've got our two ice skaters standing next to each other at center ice, and then they push off each other and move in opposite directions. What was the kinetic energy before the collision? It was zero. They weren't moving. They were just at rest. What's the kinetic energy after the collision? Some big number, right? They're both moving. They both have kinetic energy. It went from zero to some big number. We had an increase in kinetic energy. That's very typical when something blows up because we had to add energy to the system, either through an explosive or through the chemical energy in a person's body. Somehow we added energy into the system that became mechanical energy. It became energy of motion. So the kinetic energy before the collision is not the same as the kinetic energy after the collision. We know for certain when an object blows up, when one object becomes multiple objects, the kinetic energy is different before and after the collision. What happens when things stick together? When things stick together, we also know for certain that the kinetic energy before and after will not be the same. It will be less after the collision because of all kinds of reasons. The mechanical energy could be dissipated into sound, into heat, into deformation. If cars collide, metal gets bent, and the bending of metal breaks bonds and takes all kinds of energy and transforms it into types that we can't account for anymore. So the kinetic energy is not the same at the beginning and the end of the problem. The kinetic energy before the collision is not the same as the kinetic energy after the collision. When things bounce off of each other, this is tricky. We don't know if the kinetic energy is the same before and after the collision. It might be. It might not be. We have two types of collisions, elastic and inelastic. So far, I've been talking about inelastic collisions, where the kinetic energy before and after the collision are different. Now, when objects bounce off of each other, we could have a situation where the kinetic energy is the same before and after the collision, that we call that elastic, or it might be different. We call that inelastic. So just to recap, if one object blows up and becomes multiple objects, we know for certain the kinetic energy is different before and after the collision. We know that is an inelastic collision. When objects stick together, we know for certain this is inelastic. The kinetic energy is not the same before and after. The tricky one is when objects bounce off of each other. We don't know. We need more information. It might be elastic. The kinetic energy might be the same before and afterwards. Or it might be inelastic. The kinetic energy might be different. How do we know? Well, we're either told this is an elastic collision. In the problem, they might tell us that. Or we can calculate the kinetic energy before and afterwards. We'll probably have to use other techniques to solve for the velocity or something. And then once we have that information, we can find the kinetic energy before the collision, the kinetic energy after the collision, and determine whether it was elastic or not.